So we are going to take up differential equations that are of this form, and so very first, our dream would be that what if this differential equation is of this form, that is the left hand side just equals differential of a function, because in that case what happens, we can integrate the two sides and get the solution right away in the form f, or the function of xy, or a function of xy equals constant. So what we are going to do is that going to see a procedure that will help us recognize whether this is of the form differential of f. Okay, so if this is the case, that is the left hand side of our equation there is this, then we can recall that the differential of f can be written as the partial derivative of f with respect to x times the differential of x, okay, and plus the partial derivative of f times the differential of y, right? Sorry, partial derivative of f with respect to y times dy. So in this case, what has to happen is that if such a function f, if that has to exist, then what we have is that we have to have these two quantities equal to each other, right? And from here you may recognize that this means that df over dx is m. That's what I am doing to make our notation short, okay, and this equals n. Now what this will imply is this, that the second derivative of f, or with respect to x first and y next, okay, that equals the partial derivative of m with respect to y, okay. So, and likewise here what we have is just going in the similar manner. We have second derivative of f, and then switching the order of derivatives, and they are equal in the case of our m and n, okay. So that has to equal the partial derivative of n, okay, with respect to x. So what we have is that this is our test to verify that whether a differential equation formed by this is exact, that is the differential equation, if we have this equation, okay, then this is exact when if we have these two quantities equal to each other. Okay, so let's take up an example to illustrate this. Now let us illustrate this with an example. So say I have this differential equation to solve. So in this case you can see that this quantity, or this function here, is m, okay, and our n is right here, okay, and you can verify that the partial derivative of m with respect to, what we will do with respect to y, is, so here is our m, so that will be 2e to the power y, oh, sorry, 2e to the power y, and then what we have, we will use the product rule on this and treating x as a constant, of course. So here we have, we differentiated y, and then what happens? We'll have y as it is, and we will differentiate cosine xy using the chain rule to get negative x sine x y. All right, and that negative is going to make this negative sign a positive sign. Okay, and if we look at the partial derivative of n with respect to x, okay, so here we go, then what we get is, again, x, we are differentiating with respect to x, treating y as a constant, so we will again get 2 times x to the y, and then we are going to use the product rule. So derivative of x with respect to x is 1, and then we will use the chain rule on this, treating y as a constant, so that will be xy sine of xy, and that negative sign will make this into a positive, and derivative of 2y would be 0. Okay, so here we can see that the condition that we needed, that the partial of m with respect to y has to be the same as the partial derivative of n with respect to x, is satisfied. So now we would like to see how do we obtain our function. Remember the function f that we are looking for by using this. Okay, so you can see that we have, as you saw, that m is what? Partial derivative of f with respect to x, right? Remember, that's what we had noticed before. So let me make sure that we fix the font color, so give me a minute. So yes, so here we have the partial derivative of f with respect to x as m, which means that we have partial derivative of f with respect to x equals how much? That is how much of, what was our m? Our m is right here. Okay, so what we can do is we can obtain f by integrating this function with respect to x, meaning what? That we shall treat y as a constant. So when we do that, what we have is, here 2e to the power y will be treated as a constant, so we get 2x e to the power y. Okay, and then when we come to this part for integration, let me just write this here, that this means f equals, okay, and then when we come here, y will be treated as a constant, right? Also here also it will be treated as a constant. So when we integrate, what we shall have is that we will use the substitution rule, just as if you are integrating, say, cosine of 2x. All right, so the integral or the antiderivative of cosine of xy would be this, and then we will have a constant. But notice this, that when we were integrating, we treated y as a constant. So whatever is going to be unchanging in terms of x has to be a function of y. So what we get is, we get f as this entire quantity. All right, so we still have to determine who h of y will be. Okay, so let us rewrite f here. So these y's are going to cancel, and what we have is that we got sine xy only here. Okay, now remember this, that the partial derivative of f with respect to y equals what? That equals n, or in other words, that equals who is n here? N is this quantity, right? So what we can do is that this value of f that we obtained, let's use it to obtain the partial derivative of f with respect to y. So if we do that, so we are differentiating this quantity with respect to y. So what we get is 2x e to the power y. X is treated as a constant. Okay, and then minus, now we are going to use the chain rule, right? So here we have xy, and x will be treated as a constant. So this becomes x cosine xy, right? Okay, so the quantity, like this quantity here and this quantity, they have to be the same, right? Okay, so what we must have is that this has to equal this. Okay, oh, just a moment, we forgot this here. We had hy also. So then what we shall have is that we shall have dh over dy. Okay, sorry, I forgot about it. Okay, that was sitting right there. So this has to equal this value of n, and if you compare the two sides, then you can see that the total derivative of h with respect to y, and instead of partial I used total here because h is a function of y only. So dh dy is 2y, which gives, upon integration, that our h y is going to be, if you integrate to y, what you get? We get y square over 2. 2 will cancel, and now here we had a function of y only. So now as a constant, we'll get an absolute constant, and so our solution that comes out of as f equals a constant is going to be, we just replace this by y square plus equals c. We can even write that as 0 because the constant here can be adjusted according to this, or you can use a different way. Okay, so hope this was clear.